Hello, my name is Kamalpreet, and in this lesson, I'll be teaching chemistry for grade 10. So, the topic that I've chosen for this lesson is balancing of chemical reactions. So, how we are going to balance a chemical reaction with the help of coefficients, something we call it as a hit and trial method, also that we are going to cover in this lesson. So, starting with if we write any kind of chemical reaction. So let's take an example magnesium. It reacts with oxygen to give us magnesium oxide. Now, this is a chemical reaction. This is a very famous reaction where we take a magnesium ribbon and we burn in the presence of oxygen and we get magnesium oxide as a white color powder. So, this, what I have written, is a chemical reaction. On the left hand side of the arrow is something called as reactants, on the right hand side are called as products. Reactants are chemical substances which react to give products. So, this, what I have written over here, is a word equation. So, a type of equation we call it as a word equation for writing chemical reaction. So, now, the same if we are going to write in the symbolic manner in the form of symbols and chemical formula. So, magnesium reacting with oxygen. In the chemical reactions, we are always going to write oxygen in the diatomic form. Diatomic meaning two atoms chemically bonded to form one molecule of oxygen. So, they will react to give magnesium oxide. Now, magnesium oxide chemical formula is MgO. So, apart from this, we need to take care of this thing also in the while writing the chemical reaction. We need to write the states of matter. Now, magnesium is in the solid state. S stand for solid, G stand for gas, and magnesium oxide is in the solid form. Now, if we see more in detail, this is the left hand side of the equation. Anything on the left hand side over here, left hand side of the arrow is something reactants. So I'm writing left hand side, and this is our right hand side of the reaction. So if we compare magnesium on both sides, it's one atom. We can see that. Oxygen, we have two atoms on the left hand side, but on the right hand side, we have one. So we need to follow this law of conservation of mass. So for balancing, we follow this law. So it says total mass of reactants is equal to the total mass of the products. So mass can be same only if the number of atoms are same on both sides. If the number of atoms are not same, so mass can never be equal to each other, the total mass of the left hand side and the right hand side. So what we can do in chemical equation while balancing, this is a very simple method that we are doing right now in this lesson. There are multiple methods to balance a chemical reaction. So what if one thing we can't do over here, we can't put, you can say, as a subscript, this is our subscript over here, so we can't put any number over here, we can't change this subscript also. It needs to be constant because it indicates that two atoms of oxygen are chemically bonded. But we can put a coefficient. Coefficient is just a number in front of the molecule or a compound. So if we put 2 over here, this is a coefficient, a simple number. So this 2 indicates that we have two atoms of magnesium and two atoms of oxygen on the right hand side. So if we need to make it same on the left hand side, obviously we have to keep magnesium as two atoms. Now we can't write like this Mg2. This is wrong. So this is not the kind of representation that we follow. So it has to be 2 in front of magnesium. So that's why we call it as a coefficient. So we have to add a suitable coefficient so that we can balance, we can equalize the number of atoms on both sides. So if we can see, now we can count it: magnesium 2 atoms on the left hand side, oxygen 2 atoms on the left hand side, and right hand side also the same number. So it's a perfectly balanced equation. So the method that I'm using over here is very famous hit and trial method for balancing chemical reactions. So we are not doing anything, we are just using permutation combination, a suitable number, and we always have to start with the lower number. We cannot go with a higher number just like that. So let's take another example. Iron in the solid state reacting with oxygen. So this reaction require heat. So it's forming Fe3O4, that is tri-iron tetroxide. So we have multiple names. We can even call it as mixed oxide of iron. And there is another name, ferroso ferric oxide. So it's an oxide of iron. Iron has multiple oxides. So now if we need to balance it, again we need to keep one thing in our mind, that we can't change the subscript. These numbers we can't change. What we can change, what we can put over here is the number in front of these molecules, these atoms or molecules or compounds, so that they can become equal on the left hand side and right hand side. If the number of atoms are same, so if we calculate their masses, that will also come to be total masses on left hand side and right hand side. It will be exactly same. So about the masses part, we can go back to the first equation and explain that later on. So first we will balance this. So we can see this iron over here is 3 atoms. The subscript indicates 3 atoms of iron on the right hand side. So we can put 3 over here. So iron is balanced, at least that part is done. So if we go to oxygen, we have 4 atoms over here. So we need total 4. So what number we should add over here in front of oxygen so that it can become total 4? So we can add 2. So 2 into 2 will give us 4 oxygen atoms on the left hand side. So it's a perfectly balanced equation now. Then if we go to the masses part, if we need to justify that the reaction is also following law of conservation of mass. So we know that magnesium is mass is 24. So its gram atomic mass is 24. So gram atomic mass is nothing but atomic mass expressed in grams. So oxygen mass, gram atomic mass is 16. So I'm multiplying with 2 because we have 2 atoms of oxygen over here. So this will be 32 grams. Then if we take magnesium oxide, so we need to add the masses. So 24 plus 16. So this will be 40 grams. This I have kept without balancing. So if we sum it up, 24 plus 32 is 56. So the left hand side over here is 56 and the right hand side is 40 gram. So it's not matching at all. It's the mass is not same. So it's not following law of conservation of mass without balancing it. But if we if we check the mass with the balancing, like we have 2 atoms of magnesium now, if I multiply it, so 24 into 2, 48. So now if we take this 48 plus 32, so this will be 80 grams. And if we take this 40 into 2, if we do, because we have kept this 2 over here as a coefficient, 2 indicates the whole compound is multiplied into 2, its mass. So 40 into 2 will give you 80 grams. So we have total left hand side 80 gram, we have right hand side 80 grams. So that's the meaning, that law of conservation of mass, total mass of the reactant should be equal to total mass of the products. So this balancing follows law of conservation of mass. So we can take one more equation. Nitrogen gas reacting with hydrogen gas. So it's a reversible reaction. So I'm putting two arrows over here, the reversible sign, to give us another gas, that is ammonia. So I'm not mentioning the conditions, temperature conditions and pressure conditions and whatever requirements are there for this reaction. It's a very famous Haber's process we call for the manufacture of ammonia commercially. So we can get into the details later on. So right now we will try to focus on balancing of this chemical reaction. So if we see nitrogen, we have two atoms, hydrogen 2 on the left hand side, and we have one atom of nitrogen. If we have no number with any atom, that means it's 1, and hydrogen we have 3 atoms. So if we need to balance it, so what we can do, first we can start with the nitrogen. So 2 over here, if I put, at least nitrogen is done. Nitrogen we have 2 atoms, hydrogen on the right hand side will become 3 into 2. So if you multiply 3 into 2, 6 atoms of hydrogen. Now on the left hand side, there's no problem with the nitrogen, it's perfectly balanced. But hydrogen we had 2. Now how to make hydrogen 6? So with a suitable number. So 3 into 2 is 6. If I write 3 over here, so it will be 6. So these are very simple reactions which I am using. Sometimes reactions are complex. In that case, we always try to balance any other metal or element first, and we try to balance hydrogen and oxygen in the last. That's a simple rule that we follow for any complex reactions. Not for the simple. Simples, we don't have to deal with if we have only less number of reactants and products. But for complex, we can follow this, that try to balance everything else, but balance hydrogen and oxygen, specifically oxygen in the last. So that's all for this lesson. Thank you.